right. So I'm Christoph from Nuage Networks. We're actually owned by Nokia now, which is a Finnish company. Finland, yeah. So it's very international. Myself, I'm from Berlin, and I live in London as well. So that's kind of nice. So I wanted to talk about networking a little bit, and I'm glad that Container didn't talk too much in depth about it, because I'll talk about it in more detail. It's a bit of a hot subject these days because of the recent movements in the container networking space, primarily around standardization, which hasn't been so good. And obviously Amazon's entry into the networking container space, as well as supporting Kubernetes, which is a bold move and probably a stamp of approval for what we're doing here at Container Camp and the community. So I'll talk about a couple of things. Number one, a brief introduction on container networking for those who aren't familiar with container networking in depth and some of the capabilities around it and challenges. And we'll talk about CNI and CNM. What does it mean? What are these acronyms and why do I even care about it? And then who uses CNI, which is now probably the standard container networking interface in the industry, and what it means to me as a developer and a consumer in containers, and the ecosystem and the impact of Amazon. So we'll start with a brief introduction to container networking. So as you guys know, container networking is based a lot on the Linux stack, and the Linux stack presents pros and cons. It's obviously been around for a very long time, and everybody knows Linux networking pretty much. And container networking takes advantage of something called network namespaces. Now, network namespaces are part of the Linux kernel, right? So you pretty much assume that anywhere a container touches Linux, it will have a very, very nice way of interacting with the networking stack. So it'll create the isolation in the instance namespaces. It also has its own routing table, which is very convenient, as well as layer 2 isolation. And then you can also interact with tools like iproot and look up at namespaces in var run. Now that's great, and you can also do some segmentation and separation in there. But the question is that kind of capability portable for multi-cloud deployments? Right? Because now if you do want to deploy containers in the cloud, like Amazon or Google or anywhere else beyond your on-premises data center or Windows, it becomes a challenge, right? Then we've got the bridge mode, which is the default Docker mode, unless that's changed in the last couple months, which I don't know, but things change rapidly. So the bridge mode has one interface to the host namespace, and Docker nodes have one interface primarily to interact called Docker 0, which is a virtual Ethernet pair, right? Then you've got this kind of example where that interface shares the rest of the stack, right? And that presents some challenges which we'll discuss about security and isolation, because if you're on a shared network, other containers can potentially access that namespace, and that's not entirely good. So that's the bridge mode. Then we've got something called the host mode, and that's networking namespaces of the host that shall be shared with the rest of the world. And that also does some port mapping and some basic networking that your apps need. And then last but not least, the container mode. And the container mode gives you access to pods on all the hosts, and is attached to the Docker 0 interface. So this example shows two Docker containers actually touching the shared networking using two separate pods, but they're still using the underlying Linux stack, right? So you can see that with this, as far as security goes, you have an obvious challenge, because even though they're different pods, in the Kubernetes example, you're sharing your same networking view, and that is not necessarily something security people will like, and that's why we have CNI and CNM later. Then you can also turn off networking and have a no networking namespace, which is quite funny, because then there's no IP address at all. You can look up a Docker container and it will show you blank And that's handy if you just want to do some testing, and customer settings and that kind of stuff. So we'll talk about now the new world, and that's basically CNM and CNI. And it's the container networking model, that's CNM, and CNI, the container networking interface. And CNI is probably now the de facto standard because everybody's come around to it. It's got a rich ecosystem, and Amazon, being the primary cloud provider for a lot of companies, and just huge, is a blessing for this. And they have introduced the ECS task network framework under CNI last month. So first, I'd like to explore CNM, right? So the container networking model, CNM, is basically libnetwork. It's primarily driven by Docker and the Docker community. It is a specification about introducing interoperation between networks and solving this riddle that the container guy earlier talked about, is interoperability, going multi-cloud, and bringing that promise of true portability regardless of your networking infrastructure or location or cloud provider or on-premises, complete freedom, right? It is a Go-based implementation. So with Go, being the de facto language for container networking and container itself, it's very quick, very portable. There's a lot of momentum in the Golang community, etc. It is a plugin model, meaning you can interoperate different vendors and third-party networking stacks into the CNM model. And it's based on libnetwork, which is a canonical implementation of the CNM specification. There's native drivers through CNM for the things that I listed earlier, which are the non-mode, bridge mode, overlay mode for overlay networks, and Mac VLAN. And the entire spec is listed under the GitHub Docker libnetwork specification for everyone to read after this presentation, should you want to do so. There's been pros and cons around libnetwork and also who supports it. Primarily, it's Docker as a company that's driving this. So enter CNI. And CNI has become now the popular framework, which is the container networking interface. Now, it's gotten a lot of momentum, and it's originated primarily from two companies, or one company, which is CoreOS, and it's part of Rocket. For those who are familiar with CoreOS, they're the alternative to Docker. And they were the chief driver behind that project. Now it's been adopted by the Cloud Networking or Native Computing Foundation, CNFC, which has kind of put it under an umbrella on the Linux Foundation. And obviously, as of August 10th, Amazon has joined CNCF, which is the big push now around containers with Amazon ECS networking capable of supporting containers. And that's huge. So what is CNI, right? As a developer, as somebody who is writing code and wanting to parcel out containers using a networking stack, what does it mean to you? It's a runtime environment. It basically gets the network out of the way, and that's the gist of the presentation, really. As a developer sitting here writing containerized microservices, you just want the network to be out of the way. You don't want to worry about interoperability. You don't want to be able to worry about having to answer security questions or worry about multi-cloud deployments and having to worry about IP addressing spaces and IP address allocations, applying a single consistent security policy everywhere. You want to appease your networking security architects also if you're writing microservices that they're compliant. Compliance is a big deal these days, as well as regulation for anybody who is aware of what's happening with the EU GDPR directive that's coming next year, which is a huge thing for a lot of companies, especially cloud providers, cloud hosters. Anyone who's creating portable data needs to know at least where is my data going, right? So from a runtime perspective, it'll give you the configuration in an easy-to-digest JSON format, and it'll give you also the plugin, which is easily consumable, And it gives you access to third-party networking, such as what we do at Nuage, but also other vendors. And I'll talk about the ecosystem a bit later, which is really rich. That means your networking teams who might be already working with a vendor A or B or C can then give you a networking stack and a networking abstraction layer to consume for your apps, which is secure and they are familiar with. So it makes your app deployments more, easy to consume, and there's less friction between the different departments talking about it. In detail, if you look at CNI and the container networking model interface, there's some interesting things that happen, right? The networking is very well isolated, right? So you've got multiple endpoints on a networking segment that can interface into different parts of the container sandbox environment or a Docker container itself. So you can share the network securely. You can bring in another endpoint securely. And it's also got a wider adoption range with Rocket, Kubernetes using it, Kurma, Mesos, and then Amazon, last but not least. And the entire schema defines the input, right? So that input and output from the networking plugin perspective is very consistent. It's JSON-based. And if you look at the container networking interface and the drivers here, you've got a rich set of the driver features, right? So you've got the abstraction layer on the loopback plugin, the bridge plugin, the PTP plugin, Mac VLAN, IP VLAN, and the third-party networking stacks, right? And that's really important because there's a really rich ecosystem around third-party plugins. So far, so good, I hope. The network reports also everything as far as assignments go using an IPAM plugin, which is IP address management. That makes things like assigning IP allocations on premises and with your networking teams very easy. As a developer, you don't have to worry about IP address schemes and so forth. You just write your apps and deploy. So let's talk about who uses runtime and plugins. Which is very interesting because you want to know who's out there doing CNI and what's in it for me. So first of all, we are already established what CNI is, right? It's a runtime environment. So Kubernetes does it really well and is using CNI, not in entirety, which is an issue around kubelet, but that's being addressed, and I think you'll have a completely all CNI-based Kubernetes. Rocket, Cloud Foundry now, obviously, with recent announcements. As of this week, I think, for anyone who was at DevOps Days, we have now a Pivotal container service with Pivotal, Google, and I guess VMware together, and Mesosphere and Mesos and OCI. So the container can join now multiple networks across these frameworks, which is huge, so no more silos. And then we can also support the adding of containers and removing on containers more elegantly with CNI. So every runtime needs a different plugin, right? Underneath it, as I mentioned earlier, is a protocol, low level for anyone who's into networking, which I don't know if there's many of you here, but if there's a few of you here, talk to me afterwards. It's using VXLAN for the overlay vendors or overlay networks, IP VLAN, and regular layer 2 VLAN. So every runtime needs a different plugin, right? So depending on what your favorite framework is, but at least you have a single consistent networking interface into that runtime. Security and quality of service, which is a big deal actually when you get into production. We're way past the experimentation of containers, and I think what you're finding is now people are actually getting down to business on networking with containers and the day two issues. Once you've got your Kubernetes clusters up, what are you going to do next, right? Future upgrades, setting up quality of service, defining security policies for your regulatory concerns, etc., right? And then updates to the existing network configuration across multiple networks, which is a huge deal. So who's using it out there? Quick recap, we've got Docker with CNM, Docker Mon plugins, and Docker Runtime. Mesos, CNM, Docker Mon plugin, and Docker Runtime. Kubernetes execution plugin, Docker Runtime, and OpenShift, which is the commercial version from Red Hat of Kubernetes, for those that aren't familiar with it. CNM, again, being used there for Docker primarily. So CNI has not necessarily been adopted by the Docker community as readily as it has been by the other guys. So CNI is the Docker runtime for Kubernetes and Mesos, and the Mesos containerizer. And that should give you a quick overview of it, the most popular frameworks. If I missed anyone else, I apologize. There's quite a few of them. Now I want to talk about the ecosystem a little bit, because that's the huge part, right? CNI is now the de facto standard, which I believe is going to be set in stone now. So what are my benefits, right? If I'm going to be adopting CNI as a networking framework for all my application deployments, and I'm going to be using this thing as a runtime environment, regardless of my framework, what do I get out of it as far as the ecosystem and who's using it? Because I need to know, the future of it. I don't want to have to worry about another framework coming in and replacing it because of some missing capabilities or so forth. So the repo is the best place to find things out about CNI. The API specification is out there, the conventions and expressions for all the plugins, the library and the Go implementation. So it is written in Go, readily available and readable for all the runtime plugins. But the future is really bright. And the future around service chaining, which is a huge thing these days for applications that require more than just one plugin, right? You must think about things in a flexible manner, as far as some applications requiring another plugin which has capabilities into firewalling capabilities that aren't readily available to you. So you can chain these plugins together, and that's a big one. And IPv6, right? So IPv6 will be implemented with the recent spec in all the base plugins, and IPv6 is coming because we're running out of IPv4 spaces. And with the introduction last year of EC2 services and public cloud dual stack, which IPv4 and IPv6 responding to instances, you need this capability in there. And finally, we're getting it. Not all the SDN vendors or software-defined networking vendors support it readily yet. And Kubernetes itself doesn't quite do IPv6 everywhere, but it is on the radar because we're running out of IP spaces, especially if you're spinning up millions of containers. We need IPv6, and you won't believe how difficult it's been as a journey for many people to adopt IPv6. Quick recap on the main interfaces and what you're creating for the networking types in the room, and also the IP address allocation scheme, which is for you guys, the developers in the runtime environment. You need to be able to have multiple interfaces for multiple hosts, bridge interfaces, IP VLAN, loopback, MAC VLAN, PTP VLAN. You've got other plugins that do some meta abstraction like Flannel, tuning and port mapping. And then you've got also, the IP address allocation, which is like DHCP. Assign me out those IP address pools in a fashionable manner with metadata kept in JSON, so I know that I can address these containers with my IP address space pool consistently and programmatically. I don't have to go into Excel spreadsheets or look up information in my EC2 instances. It can all interact to IPAM, which is an IP address mechanism. And then you've got a sample, of different plugins as well. And I'll talk about the ecosystem, which kind of gets to the point about this thing being very big now and a little bit confusing to enterprises and companies doing containers in production with various departments involved and some of the silos that do occur in these departments. So it's a rich ecosystem. As you can see here, we've got the container runtimes, which are, growing and being adopted widely. I think Kubernetes being probably the most popular right now, Mesos and Cloud Foundry and Rocket. And then the rich third-party vendor ecosystem where you see Nuage, and we've recently announced our CNI repo and plugins, and we've also created some nice little scripts and code to build plugins in RPM format, etc. You've got Calico, you've got Weave, mentioned earlier, and they're all doing wonderful work. Cilium, Contif, and Rancher, and two more just got added. I checked the repo, which I don't really know that well. One's Linen. It's a confusing space a little bit because you have to decide who you're going to invest your time in. But with service chaining coming along, which is a concept that's really popular right now, especially in the telco service provider space, where containerized virtual network functions are incredibly hot right now. You might have heard of things called VNFs, or virtual network functions. That means literally containerizing a firewall capability into a container and spinning it up on a compute node, and then chaining it to other workloads for video streaming or something else that might be happening inside the service provider. That's a big push now, right? So you can pick multiple of these finally and have them interact with each other. And the ability to be portable, right? So you can take Cloud Foundry-based Kubernetes networking, which is currently very isolated. It has its own load balancer, for example, and bring that out and spin it up in Google Compute, which also has its own load balancer. But with the abstraction in CNI and the things that are happening in the adoption, you can go fully multi-cloud. So you can consume different load balancers, you can control different firewalls and traffic steering and all kinds of exciting things which you couldn't do before by combining these different plugins. I'm conscious of time in 9 minutes now. So the big one is, Amazon, right? So there's a guy called Adrian Cockcroft who came out recently and talked about adopting CNI. And I woke up to that because I didn't really think that Amazon would be into this at all, because it's not really in their interest. I think they kind of like people to be in the Amazon AWS cloud with everything. However, I think that's really cool, right? That gives us a blessing and the possibility of having Kubernetes clusters as a service in Amazon potentially in the future, which might happen, right? So with the ECS task networking capabilities, the repo is now out. I just checked it before the presentation. It's only a few days old, but you can see the ECS task plugin, which allows you to register with the ECS service your containers. They have an IPAM plugin and a bridge plugin. So you can get your address scheme for IP address allocations, elastic IP addresses out of Amazon into your Kubernetes cluster. Everything's defined in a standard fashion, right? So your ECS instances and ECS ENI network is defined in JSON, and you can see here I've got a CNI version, I've got the ECS type, the IPv4 address scheme right now, just for demonstration purposes, and the block instance metadata, right? So it's all consistent. You can go multi-cloud. Fantastic news. I'd like to close by inviting you guys, I think that's my beep, right? To try out Nuage. We have an online experience for container fans, and it's called Nuage X. And I invite you to log in for free and then spin up your favorite containerized workload on Packet.net, Amazon, Google Cloud, or your own laptop if you want to, and then download our CNI driver, which is out as of a few weeks ago, and then build it and run it and go for it. So thank you very much.